What's going on, guys? Happy Thursday. Um, we're winding down the year. We're almost done, right? May 8th. If you're passing May 8th, you're done. From here on out, make it your goal. Get your grade as high as possible before you're done, because your senior year self will thank your freshman year self for boosting that GPA as much as you can. So take my advice, get that GPA up, take advantage of all these opportunities to get your grade up. We're moving on to the final unit. This unit's going to be super useful. It's going to be pretty easy. And it's going to be a way to kind of send you off into the rest of the math classes you're going to take during your high school career. And it's going to be a really good way to kind of wrap up what we've learned so far. So, this last unit, we're going to compare linear, exponential, and quadratic functions. The three types of functions we've learned this year. This final unit, we're going to look at all of them together, be able to tell them apart, and kind of just a good way to wrap up everything we've learned. So today, what we're going to learn is how to tell the difference between a linear, exponential, and quadratic function, both graphically and based on their equation, right? Remember that there's three ways that we see functions: graphs, tables, and equations. Today, we're just going to focus on the graphs and the equations of these three types of functions and see how we can tell them apart. Let's start with equations, okay? I'm going to make this really quick, straight to the point. If we are looking at these three types, linear, exponential, and quadratic, to tell if an equation is linear, the x will not have an exponent, okay? Whoops. The x will not have an exponent, like y equals 5x plus 1, right? mx plus b. Y equals 1 half x, 2x, right? When you have an x without an exponent, you've got a linear function. Or if you just have a constant like y equals 5, that's going to be a horizontal line. That is also linear, right? So constant, or if x doesn't have an exponent, it's going to be linear. And then remember, exponential is where the x is the exponent, okay? 3 to the x power, that x is an exponent right here. That means it's exponential. 5 to the 2x, exponential. 4 to the x, exponential, right? We've talked about that. And then finally, quadratic. It's where the equation has an x squared. And more specifically, that 2 is the highest exponent, the highest power that you're going to see in the equation. So 2x squared plus 3x minus 5, that 2 is the highest exponent. That means this is quadratic. X squared plus 9, quadratic. X squared, quadratic, right? You see what I mean? So we've talked about all this before, but now we're kind of putting it together. So that's how to tell the difference between linear, exponential, and quadratic equations. Now let's move on to a couple of examples really quick. So linear, quadratic, or exponential. This first one, it's exponential. And why? Because the x is the exponent. This next one is quadratic because the highest power I see is 2, x squared. Third one, part C, that is linear because we see 9x, right? X doesn't have an exponent. And there's no other x's with exponents. It's linear, right? And then finally, this last one's exponential because this x is the exponent, right? This 2 is part of 2x, which means that sometimes people will think that means it's quadratic. If x is in the exponent, it's got to be exponential. All right, so that's equations. Let's move on to graphs. And this is the easiest part for most everybody. So linear graph, obviously a linear graph's a line. And we learned this for a lot of first semester, right? Linear line. Exponential, right? It's that J curve, right? This is a backwards J curve, but as you know, you guys remember that the exponential decay, or if this was flipped around, exponential growth. Pretty easy to tell exponential. And then quadratic, it makes that U, right? It's that parabola. Okay. And I think you guys are pretty good at telling the difference between those three. So that's how you tell the difference between the graphs. And if we're looking at some examples, obviously this is quadratic because it's a parabola. This is exponential, right? We see that exponential decay right there, right? We can tell the difference between quadratic and exponential because this thing kind of it levels out at its asymptote, whereas a quadratic makes more of a U shape with its parabola, right? Part C, that's obviously linear because it's a line with a negative slope. And then D is kind of a trick one. It's none of them. It's absolute value, right? So that's how to tell between graphs. So quick video today, just be able to tell the difference between linear, exponential, and quadratic based on their equations and based on their graphs. And we'll learn how to tell the difference based on their tables a different day. So do the assignment for today. Get that easy 100. It's just a quiz. It'll be quick. Boost that grade up, right? Even if it's 1-2 points, I promise you'll be thankful in the end. So listen, have an amazing rest of your day, and we'll talk soon.